Okay, here we have a bath that takes 240 litres. So in the y-axis we have the volume, which is in litres, and in the x-axis we have the time that it takes to fill the bath in minutes, or empty the bath. One of the graphs shows the connection between the volume and time you're filling. And which of these two graphs is going to be that you fill the bath? Well, it must be the one that starts with 0 water in and then continues for 12 minutes until the bath is full. So the blue line is representing filling the bath, whereas the green line is representing emptying the bath. You're starting at a volume of 240 and you are emptying the bath in 8 minutes. So the questions are, how long time does it take to fill the bath? Well, that must be the blue curve, and you can see that you fill the bath. It's filled at 240, and you just go along the graph and read how many minutes does it take you to fill the bath. And you can see that it takes 12 minutes to fill the bath. So that's answering question A. How long time will it take to fill the bath halfway? Well, then you would read along your curve at half the volume. You can see that this curve is proportional, so you would expect it to take about half the time. I know my diagram isn't perfect here, but you would expect it to take 6 minutes to fill the bath halfway. How long time does it take for half of the water to run out? Well, if it takes 8 minutes for all of the water to run out, it's going to take 8 minutes divided by 2 for half of the water to run out. And we can also look at that from the graph. We go to the point 120, go along until we meet the green graph, which is the one that's showing the running out, and we can see that at 4 minutes half of the bath has emptied. How many litres per minute does it take to fill the bath? Litres per minute. Well, we can see that 240 litres takes 12 minutes. So litres per minute will be the total volume divided by the number of minutes it takes, which will be 240 divided by 12. 12 goes into 24 twice, giving you 20 litres per minute to fill the bath. Then it says, how many litres will it take for the bath to empty? Well, same thing here for E. It takes 8 minutes for 240 litres to empty the bath. So 240 litres takes 8 minutes. So using the same formula, the total volume divided by the number of minutes it takes to empty. 8's going to 24 3 times, giving you 30 litres per minute for emptying and 20 litres per minute for filling. Okay, then we've got some formulas here. Let's just make some space down here. It's wondering, what are the two formulas that we would be able to demonstrate our equations of a straight line? For filling the water, so we're now on F, we have 3 options. Filling the bath. We have 3 options. We have that the volume is 20 times x, or the volume is 30 times x, or the volume is 12 times x. Well, we've already worked out the gradient by taking the rise, which for filling the bath was 240, and divided it by the time it took, 12, giving us 240 divided by 12, giving us a gradient of 20. So we can see that the only curve that fits in with that is the volume is 20x. We're expecting a gradient of 20. We got one of 20 in our answer to D. So filling the bath, the only possibility is that V is 20x. The gradient is 20. By the same mechanism, we worked out that the gradient for emptying the bath was, the volume divided by the time was 30x. But we've got to remember that this graph is in a negative. It's going backwards, sloping backwards. So what would we expect for the formula for this graph? Well, we have three choices. 240 minus 30x, or the volume would be 240 minus 20x, or the volume would be 30x. Well, we know that it can't be this one, the bottom one, because we know that the intercept plus c is 240 here. So we're expecting every straight line equation to have the form y equals mx plus c. The intercept number is going to be very high for the green curve. It's going to be 240. And the negative gradient, we've already worked out that the rise over run, in this case, in the green one, the rise was 240, and the run, in this particular case, was 8. So we worked out that the gradient was 30. So the only equation that can be correct for this particular is, so the only equation that could be correct for the green straight line is that the volume is 240 minus 30x, which is the same as minus 30x plus 240, which is in the mx plus c mechanism that we are used to. Okay.